Yes, good evening all of you. Yes, good evening all of you. This is Upendra, Physics faculty. Today we are discussing about the concept of kinematics. So we will discuss the conceptual based problems we will discuss, and some more problems we will discuss today. So before that one, this is Upendra Physics faculty, and we are working under in Spark Academy. If you want to join in Spark Academy, I have taken the NEET and JEE and Eamcet string batches are separately going on. Let us try to join in this. Okay. So, see this last previous 2 weeks we were discussed about the kinematics in this motion in a straight line. We are discussing motion in a straight line. We are discussing. So, last week I was discussed about some problems based on the different accelerated motion equations, and unique problems we were discussed actually. So today we will discuss some more numerical problems like that. Let us try to check. I will share the screen. So see this motion in a straight line problems I was taken here. That is, a person is traveling along a straight road for the first t/3 time with a speed v1, and for next 2t/3 time with a speed v2. Then the mean speed v is given by, he is asking. So a person travels along a straight road for the first t/3 time with a speed of v1, and for the next 2t/3 time with a speed of v2. The mean speed we want to calculate. So let us try to check it. Mean speed we have to try to calculate. We have to try to calculate the mean speed. So here, based on the given content, this is a lie. So v1 is equal to, so based on the given content. So first question solution I am taking here. So let us try to check it. Based on the given content, I want to try to find out what about the V average. V average is equal to, we know, that is distance divided by time. Distance divided by time. We know this one. So distance is nothing but what? There is nothing but speed into time. Speed into time divided by time. Now, what about the speed? Speed you have to take in terms of the speed and time. Let us try to take speed and time based on the given data. So V average is equal to V1 into T divided by 3 plus, that is V2 into 2T divided by 3 I was taken here. Check it here. So a person travels along a straight road for the first t/3 time with a speed of v1. So v1 into t/3, and another next 2t/3 time with a speed of v2, means v2 into 2t by 3 hours taken. So divide by time taken is t by 3 plus 2t by 3. T by 3 plus 2t by 3. Then let us try to take V average is equal to V1 divided by, so you have taken common t, then what you will get, t will get cancelled here, then V1 divided by 3 plus 2V2 divided by 3 and totally divided by 1 by 3 plus 1 divided by 3. So is that what? So 1 by 3, 1 by 3. So t by 3 plus 2t divided by 3. So 1 by 3 plus 2 divided by 3. So you will get 3 by 3, 3 by 3. It is equal to 1. Then finally you will get here. So V1 plus 2V2 divided by 3. You will get answer here. So check it this answer. So which option is correct option? So V1 plus 2V3 divided by 3. First option is the correct answer. Right? So right. So next question, let us try to read. So second question, a boat covers certain distance between two spots in a river, taking T1 hours going downstream and T2 hours going upstream. What time will be taken by boat to cover same distance in still water, he is asking. So based on the given content, I will try to take like this content. So based on the given data, I will try to take for upstream separately and for downstream separately I will treat. So for upstream I am taking here. For upstream is equal to, so change in velocity is V minus U is a change in velocity. Here what is the V? V is nothing but an speed of the man or velocity of the man, and U is nothing but an water velocity. Water velocity. And next one I am taking here for downstream. For downstream, that is nothing but an V plus U I am taking here. So for downstream and for upstream, because in the upstream both velocities are opposite to each other, so for downstream both velocities are equal direction. So let us take time taking for to reach the upstream, that is t is equal to distance divided by change in velocity, that is d divided by v minus u I am taking here. So based on the given content, so what is the time taken here? So t1 hours and t2 hours he is given. So t1, t2. So it is downstream and t2 hours going upstream. So I am taking here t2 hours. So t2 is equal to d divided by v minus u. So based on this one, d is equal to t2 into v minus u. This is, let us take this one as a first equation. Right. So next one, for downstream I am taking here t downstream I am taking here. So time for to take to downstream, d divided by distance divided by v plus u. So that is velocity. So t time taken for downstream, here it is, that is t1. You know this one. So t1 is equal to d divided by v plus u. Then d is equal to t1 into v plus u. T1 into v plus u. This is equation 2 I am taking here, right? So now what he is asking, in still water how much it is existed. So time taken to still water. So time taken to still water, that is d divided by v, and t still is equal to distance is nothing but m. You will get actually 2 t1 t2 divided by velocity v is nothing but m, t1 plus t2, here it is there. So how we will get This is actually directly you have to take on this one, no need to worry. But how we will get this one, let us check it. Based on the first equation and second equation, both equations are only representing the distance, right? Same distance it is covered, so upstream and downstream. Let us try to equate the two equations. So equate two equations. Equate two equations, 1 and 2 equations. Equate 1 and 2 equations. What we will get? Let us check it. We will get V minus U into T2 is equal to V plus U into T1. V plus U into T1. Now you have to try to take on this one. V T2 minus U T2 is equal to V T1 plus U T1. So let us try to take on final velocity is one side and initial velocity is one side. So V T2 minus V T1 is equal to U T1 plus U T2. So solve this one common, take V is a common, T2 minus T1 is equal to U common, T1 plus T2. So now what you got here, that is initial velocity U. Initial velocity U is equal to V into T2 minus T1 divided by T1 plus T2 you will get here. So you got initial velocity of the particle here. So let us try to substitute that initial velocity in any equation. In any equation you will get the solution. So I will substitute in first equation, that is D is equal to T2 into V minus T2 into V minus U. So D is equal to first equation I am taking here. D is equal to V minus U into T2. Let us try to substitute the initial velocity. So V minus initial velocity is V into T2 minus T1 divided by T2 minus T1 divided by T1 plus T2. So V into T2 minus T1 divided by T1 plus T2 you will get here. So into totally multiplied with T2. Check it. So V is a common value here. So V is a common value. So here you will get what? V into T2 is also you will take common, no problem. That is V T2 you have to take on common. Then you will get here 1 minus T2 minus T1 divided by T1 plus T2. So that is equal to VT2 into, let us take an LCM here, T1 plus T2. Then this is T1 plus T2 minus T2 plus T1 divided by T1 plus T2. So here D is equal to what you got here. Then D divided by V, you have to transpose this V. You will get T2 into minus T2 plus T2 will get cancelled. So inside of the brackets you will get T1 so inside of the brackets you will get so inside of the bracket you will get 2 T1 you will get here. So totally you will get 2 T1 T2 divided by T1 plus T2 you will get answer. So this is the final answer what we will get here. Instead of that one you have to try to remember. So D divided by D divided by V you will get actually, so time taken to still in water. So that's we wrote here directly. Check it in the third slide. So directly we wrote here. So T still is nothing but D divided by V. Directly you have to remember this one, 2 T1 T2 divided by T1 plus T2. How we got this one? By using the upstream and downstream timings. So based on that one we got this equation. So this is formula. So let us try to remember this one. So the option 3 is the correct answer in this case. Let us try to check it the third question here. The initial velocity of a particle is u at the time of t is equal to 0, and the acceleration a is given by alpha t power 3 by 2. Which of the following relation is valid for that one, he is asking. Which of the following relation is valid? Yes, which of the following relation is valid, he is asking. Let us try to check it. Acceleration here in this question, observe in this case, acceleration whatever it is given, that is a function of time actually. There is a function of time. So let us try to take a, so to solve the third question, what is the given content? Given content, acceleration, that acceleration a is equal to alpha into t power 3 divided by 2. Means here acceleration is a function of time. It is a acceleration is a function of time too. So we know this. We know what is the acceleration. Acceleration is equal to rate of change of velocity. Means you have to transpose dt here. That is dv is equal to a into dt. Right? So up to where you have to, so you got actually small value, but we want to find the final velocity completely. So to find the final velocity, then I want to take from initial velocity at the time of t is equal to 0 up to the final velocity I want to find. So let us try to check it. Integrate both sides. You will get integrate dv is equal to integration of a into dt. This is from initial velocity u to v intervals, and the timing is 0 to t I am taking here. So when you integrate this one, what you will get? So this is dv is nothing but integration of dv is nothing but an v. So from u to v, that is equal to a, you have to take a a is value already being given, function of time t. So substitute that a function value. So that is integration of alpha t power 3 by 2 into dt. That is from 0 to t you will get here. So when you substitute the values, so v minus u is equal to, when you try to integrate that one, so alpha is a constant value. So integration of t power 3 by 2. That is, so t power 3 by 2 plus 1 divided by 3 by 2 plus 1 here. So let us try to substitute that one. So 5 by 2 divided by 5 by 2. So t power 5 by 2 divided by 5 by 2 here. So now you have to take on this one numerator. 5 by 2 is nothing but a 2 by 5. In the next step, what I will take here, v minus u is equal to 2 by 5 into alpha into t power 5 by 2 you will get here. So finally, the final initial velocity, final velocity v is equal to u plus 2 by 5 alpha t power 5 by 2 you will get answer. So this is the answer. Let us check it. U plus 2 by 5 alpha t power 5 by 2 you will get answer. Check it in this. So v is equal to u plus 2 by 5 alpha t power 5 by 2. Third option is the correct answer in this case, right? Okay, so check it the next question. Here, the fourth question, a particle moves in a straight line. A particle moves in a straight line and its position x at a time t is given by, time t is given by x square is equal to 2 plus t. its acceleration is given by his asking. Anyway, he given distance, position actually he given. So position x square with respect to time he is given, x square is equal to 2 plus 3. I want to find out the acceleration. Easiest problem only. So fourth problem I am solving here. So what is the given content here? Given content is equal to x square is equal to t plus 2, means x is a position here. So let us try to take on this one. When you reciprocal this one, 1 by x square is equal to 1 divided by t plus 2. So keep like this equation. So x is equal to, when you taken this square transpose, then you will get the square root there. X is equal to square root of t plus 2 here. Now differentiate both sides with respect to t. When you differentiate both sides, dx divided by dt is equal to, so d by dt of square root of t plus 2. When you take on the differentiation there, so dx divided by dt is equal to, when you differentiate square root of t plus 2, you will get square root of t plus 2. How you will take here? That is t plus 2 whole power 1 by 2. That is looking like an x power n. The meaning is n into x power n minus 1 you will get here. Means when I try to differentiate that one, t plus 2 whole power 1 by 2 into t plus 2 whole power 1 by 2 n minus 1, right? So here you will get, what you will get here, that is minus 1 by 2 you will get here. Just take it this one. So 1 by 2 into t plus 2 whole power, in power what you will get, that is minus 1 by 2. What is dx divided by dt? It's a velocity. Again differentiate with respect to t. Then what you will get, that is d square x divided by dt square, that is equal to d by dt of, again you have to differentiate this one, 1 into t plus 2 whole power minus 1 by 2. Taken 1 by 2 outside, then you will get minus 1 by 2 into t plus 2 whole power minus 1 by 2 minus 1. So finally you will get, this is power value you will get, that is nothing but an minus 3 by 2 you will get here. Anyway, this is minus 1 divided by 4 you will get here. So finally this is minus 1 by 4 into t plus 2 whole power 3 divided by 2, that is minus 3 divided by 2 you will get here. So this is nothing but an velocity. This is nothing but an velocity v, and this is another one is nothing but an acceleration, right? Acceleration you got here. So both values you got here. Let us try to take on these values. So the same acceleration value I am taking like this. Acceleration a is equal to minus 1 divided by 4 into t plus 2. 1 t plus 2 when I taken outside. Let us try to take on remaining t plus 2 values. So t plus 2 minus, sorry, this one, so denominator one, so 1 divided by 2, because in numerator this t plus 2 power minus 3 by 2, when you take on this one in denominator, the power value will get plus. So that's why 4 into t plus 2 into t plus 2 power 1 divided by 2. So finally you will get, so 1 by minus 1 by 4 into 1 divided by t plus 2 into 1 divided by square root of t plus 2. Square root of t plus 2. This one only we got now. So finally acceleration is equal to minus 1 by 4 into 1 by t plus 2. 1 by t plus 2, what is the value of 1 by t plus 2? 1 by t plus 2 is nothing but an 1 divided by x square. So this is 1 divided by x square. It is multiplied with 1 divided by square root of t plus 2. That is nothing but 1 divided by x is the value. So final answer what you will get here, that is minus 1 divided by 4 into x power 2 x, that is x power 3, you will get answer here. So a is equal to minus 1 divided by 4 x power cube, you got here answer. Second answer for second option is the correct answer. So next one is an fifth question. Let us try to check it the next question. That is fifth question. A body is projected vertically upward with the speed 40 meter per second. The distance travelled by body in the last second of upward journey is taken. G is equal to 9.8 meter per second square, and neglect effect of the air resistance is asking. Right? So check out that question. So next, fifth question I am doing here. So fifth question. So as the given content, let us try to draw the picture. This is the picture. So based on the given content, a body is projected vertically upward with speed of 40 meter per second. The distance travelled by the body in the last second of upward journey. In the last second of upward journey is he is asking. Means in the last, so it is projected, body is projected vertically upward direction with initial velocity used with a velocity of 40 meter per second. Anyway, final velocity when it reaches the maximum position v is equal to 0. So before 1 second, when it reaches before 1 second, this is, let us try to consider x1 height it was reached, and here let us try to consider here x2 it is there, right? So these total timings are in this timings are equal. So as the motion under gravity is symmetry, means there is no external forces are acting in that. So distance travelled in the last second, distance travelled in the last second, it should be equal to first second, means last second of ascent. You have to write down ascent also. So last second of ascent. So last second of ascent, it should be equal to distance travelled in the first second of descent. First second of descent. So what I want to do, so let us take the distance, it is upward direction, here it is the, means this distance or this height whatever it is covered by the particle, that is in negative, means opposite to the acceleration due to the gravity. So I am taking here minus x2 is equal to ut, because I am using just normal formula only, s is equal to ut plus half at square. When you consider the particle is in vertical motion, you have to take here h is equal to ut minus half gt square. Then x2, instead of height I am taking here x2, minus x2 is equal to ut minus half gt square. So t value I am taking here 1 second, given already. So last 1 second I want to find. So x2 is equal to, means minus it is there, both sides you will get cancelled. Then initial velocity of the particle, let us try to consider initial velocity of the particle is equal to 0. Then x2 is equal to half into g value is 9.8 into 1 square. So when you cancel this one, you will get x2 is equal to 4.9 meter you will get. So this is the height covered before 1 second of time. So this distance is a constant for every body thrown with any speed, that you have to remember, right? Let us check it the next question. So next question, sixth question I am taking here. So the position of a particle. The sixth question, the position of a particle moving along x-axis given by x is equal to minus 2t cube plus 3t square plus 5 meter. The acceleration of particle at the instant its velocity becomes 0 is his asking. So the position of the particle moving along x-axis. So x position he given actually. The acceleration of the particle, the instant its velocity becomes 0 is okay. So let us try to write down the given content here. So sixth question I am taking here. So what is the given equation? Given content, position x is equal to minus 2t cube plus 3t square plus 5 meter. Plus 5 meter. So let us try to differentiate this one with respect to t. So dx divided by dt is equal to minus 6 t square plus, so 3 2s are 6, 60. Aishu, disturb అవుతుంది Aishu. So 60 plus 0 here it is, right? So now this is nothing but and what? It's a velocity. Now let us try to differentiate again with respect to t. So d square x divided by dt square is equal to again minus 12t plus 6 you will get here. So finally, so for velocity v is equal to 0, then what about the time? Time t is equal to 1 second here, right? Because 6t is equal to 6t square, right? Whenever you have to take on this velocity will be 0, what happened? Check it. So minus 60 is equal to 60 square is equal to 60 you will get here. So t will get cancelled, 6 also will get cancelled. What is the remaining? So at the time of t is equal to 1 second, then velocity will be 0. That is it. Then now you have to substitute acceleration at the time of t is equal to 1 second, that is equal to minus 12 into 1 plus 6, you will get minus 6 meter per second square. It is not an acceleration, it is a retardation. The second answer is, second option is the correct answer, minus 12 meter per second square. Minus 12 meter per second square. Okay. So let us check it. The next question is seventh question here. A car traveling at a speed of 30 km per hour is brought to rest in a distance of 8 meter by applying brakes. If the same car is moving at a speed of 60 km per hour, then it can be brought to rest with same brakes in his asking. So car traveling at a speed of 30 km per hour is brought to rest in a distance of 8 meter. So means with a speed of 30 km per hour, the particle travels the distance 8 meter by applying the brakes. If the same car is moving at a speed of 60 km per hour, then it can be brought to rest with the same brakes in how many meters the particle will cover if the particle contains a 60 kilometers per hour speed he is asking. So check it, this is the seventh question. So distance covered by the particle. So let us try to use accelerated motion equation formula. V square is equal to u square plus 2as formula only. So final velocity will be 0, that is equal to, so final velocity will be 0, that is so u square plus 2a, let us take an s is the distance, then 2ad is equal to minus u square, you will get d is equal to minus u square divided by 2a, right? So I am taking here what about what you observed here? This distance is directly proportional to the u square. This will be the actually what you will get here. This is the negative value here. The initial velocity. So initial velocity is negative, it is there, but don't consider that one. Here d is directly proportional to the square of the velocity. D is directly proportional to the square of the velocity. Then in the next case, for example, let us try to consider the particle maintains the initial velocity, double the velocity it is, because it is u is 30 meter per second and u dash, let us consider, that is 2u, right? U dash, let us try to consider 2u means 60 kilometer per hour it is there. So d dash distance it was covered, means it is also directly proportional to 2u whole square. So when I taken like this, so instead of taking like this, let us try to take u dash is equal to 2u, then d, both are directly proportional. I will take like this, d dash divided by d is equal to 2u whole square divided by u square. So d dash divided by particle covered initially with the velocity u, it was covered 8 meter per second, sorry 8 meters it was covered, that is equal to 4 u square divided by u square. So u square will get cancelled, as d dash is equal to 32 meters the particle will cover if the particle contains already the particle existent with a speed of 60 kilometer per hour, then it can drop to rest with the same brakes it will apply. Within 32 meters the particle will cover, right? So let us check it the next question. 8th question here is there. A ball is dropped from a bridge of 122.5 meter above a river. After the ball has been falling for 2 seconds, a second ball is thrown straight down after it. So initial velocity of second ball so that both hit the water at the same time is his. So ball is dropped from a bridge 122.5 meter above the river. Okay. So after the ball has been falling for 2 seconds, a second ball is thrown straight down after it. So from the same height, from the same bridge, the ball is thrown in a straight away down after it. So initial velocity of the second ball is asking so that both hit the water at the same time. So I want to find out second ball initial velocity in this case. So let us take an 8th question we are discussing. So for the first ball I am taking here information, that is minus h is equal to initial velocity 0, so that's why minus half gt square it is there. So based on the given values, let us try to substitute all the values. Minus will get cancelled here because the height of the ball is opposite to the direction of the acceleration due to gravity. So 122.5 is equal to 1 by 2 into 9.8 into t square. So when we try to calculate this one, so t square we will get here, that is 25. Then t is equal to 5 seconds we will get. T is equal to 5 seconds. So next one is another ball dropped after 2 seconds. Another ball dropped after 2 seconds. So it took only 3 seconds of time to reach, right? It took only 3 seconds of time to reach the river. 3 seconds of time to reach the river. Because the first ball will take 5 seconds completely. So that's why initial, after dropping the first ball, he dropped the second ball after 2 seconds of time. Means Finally, both balls will reach the river within the same time. Means the second ball will travel only 3 seconds of time. So based on that one, let us try to take same formula I am applying here. That is 122.5 is equal to initial velocity u minus u into 3. Sorry, I will take another page. No problem. It's a little bit bigger. For the second ball, I am writing equation here. So minus 122.5 is equal to minus u into 3 minus half, means t is the 3 seconds I am substituting here. So sorry. So ut minus half gt square, that is minus into 9.8 into 3 seconds 3 square. When you try to calculate all the values, you have to substitute 3u minus, so this is 4.9 you will get here. So when you try to multiply and substitute all the values, you will get here, that is u is equal to initial velocity, u is equal to 26.1 second. So when you have to try to take a minus here, you have to take here also minus, otherwise you have taken plus here. Okay, so 26.1 second here you will get. So the initial velocity of the second ball, what you got here, this is initial velocity of the second ball. Initial velocity of the second ball we got here, that is u is equal to 26.1 second here you got here, right? So the solution is 26 point, sorry, it is velocity now, it is in meters per second, sorry, meters per second. So initial velocity u is equal to 26.1 meters per second you got here. So this is third option is the correct answer in this case. Let us try to check it. A balloon starts rising from ground. 9th question. The balloon starts rising from ground from rest with an upward acceleration 2 meters per second square. Just after 1 second, a stone is dropped from it. The time taken by the stone to strike the ground is nearly. So balloon starts rising from ground from rest with an upward acceleration 2 meters per second. Just after 1 second, a stone is dropped from it. The time taken by the stone to strike the ground is nearly his asking. So next one is an 9th question we are discussing here. So through the given data, initial velocity of the stone is equal to 0 here and acceleration is equal to 2 meters per second square. So the velocity of object after 1 second. After 1 second, how it is existed? Let us check it. Accelerated motion equation, first equation I am taking here. B is equal to u plus at. Then V is equal to how much we will get. So first you have to try to find out the displacement of a particle. Displacement ut plus half at square. Initial velocity u is equal to 0 plus half into a value is acceleration 2 here it is there and time is for 1 second. Then s is equal to 1 meter the object was covered. Now you have to substitute here. Initial velocity is 0 and acceleration is 2 and it is 1. So v is equal to 2 meters per second final velocity you got here. So distance s is equal to 1 meter you got here, right? So after separating from the balloon, so this is balloon and stone both combined to each other, whatever it is existed. But now after separating the balloon, after separating from the balloon, it will move under the effect of gravity. Means stone will fall under the effect of gravity, right? Stone will fall under the effect of gravity. So under the effect of gravity, then now you have to take an minus h is equal to vt minus half gt square, minus half gt square. So at that situation, whatever stone contains an velocity, that is only the initial velocity you have to consider. So now you have to substitute all the values. So minus 1 is equal to, means h height is 1 meter, it is there. So 2t minus 4.9 means 1 by 2 into 9.8. When you cancel this one, you will get 4.9, you will get into t square. Now 4.9 t square, that minus 2t minus 1 is equal to 0. When you try to apply the quadratic equation, then you will get the time value. So through by using the quadratic equation, you have to try to solve this one. Then you will get t is equal to 0.7 seconds, you will get answer. So 0.7 seconds you will get answer. I got on 0.7 seconds here. Here 0.7 seconds is their answer. So I hope you understood, right? So let us check it the 11th question. So the 10th question is normal only. So that is based on the constant velocities only existed. Now you have to consider the next question, that is 11th question. So the displacement time graph for two particles A and B is as follows. So you want to find out the velocities of the two particles ratio we want to find. Two different slopes are there. So what you know about the slope? The slope is nothing but tan theta. The slope, how you have to represent the slope in this case? The slope you have to represent, that is tan theta, right? So like this we want to represent. So next question I am taking here, that is 11th question. So I am taking like this. Hope you know the slope of line A. The slope of line A is tan 30 degrees and slope of line B is tan 60 degrees. What it will represent? The slope value will represent the velocity. So velocity of object A to the velocity of object B. So VA divided by VB, it is tan 30 degrees divided by tan 60 degrees. So tan 30 degrees is 1 divided by root 3 divided by tan 60 degrees is root 3. So there is 1 divided by 3, you will get answer. So the ratio is VA is to VB is equal to 1 is to 3 is the answer. So this is 1 is to 3 is the answer. So fourth option is the correct answer here, right? Fourth option is the correct answer. Next, 12th question, let us try to check it. Two cars A and B are moving in the same direction with velocities 30 meter per second and 20 meter per second. When car A is at a distance small d behind the car B, okay, the driver of the car A applies brakes producing uniform retardation of 2 meter per second square. There will be no collision. There will be no collision when, so they given relation between the distance to distance, okay. So can be moving in the same direction of velocities of 30 meter per second and one is 20 meter per second. Means car A is 30 meter per second, car B is 20 meter per second, okay. So object A and object B both are there. So object A and object B both are there. So this is a 12th question I am taking here. So the object A is moving forward direction, object B is also moving forward direction, but object A is in applying brakes and it got retardation, that is minus 2 meter per second square, right? So in between the distance, how much it is there, let us consider this is small d, and object B contains an 20 meter per second velocity and object A already contains an 30 meter per second velocity. So this is the actual given data. So based on this one, V square is equal to U square plus 2AD. Let us try to take and apply this one. So final velocity is 0 because he applied the brakes and he got a retardation. Final velocity will be 0 initially. So when you consider a relative velocity, how much it is there, that is, so initial velocity of that one. So relative velocity I am considering here, and relative displacement also I am taking here, that is 10 whole square plus, so whenever retardation is there you have to consider here minus, so minus 2 into relative distance, right? So now 100 divided by, so 100 divided by 2 to the 4 you will get here, 100 divided by 4 you have to take here less than, so this is minus 100, minus will get cancelled. So okay, less than or equal to relative displacement, right? So when you cancel this one you will get, when you divide this one you will get 25. So whenever you will get cancelled, so this is greater than, so D relative, okay, so D relative means relative displacement should be greater than or equal to 25 meter. So I got this one, check it. Relative displacement is greater than or equal to 25 meter. Because relative velocity I consider, so relative velocity for in between the both objects, how much it is, 10 it is existed, yes it is correct for, check it. So D relative is greater than or equal to 25 meter. So greater than or equal to 25 meter. Okay, the third option is the correct answer here. You only given greater than only anyway. So third option is the correct answer in this case. Next one, a ball is dropped from the top of a building of height 80 meter. At same instant, another ball is thrown upwards with a speed of 50 meter per second from the bottom of the building. The time at which balls will meet is, so what time the balls will meet? Very easy question. Let us check it. 13th question. So based on the given data, through the data I am taking here time. So time is equal to height divided by, so relative velocity I am taking here, that is equal to 80 divided by 50. So when you cancel this one, you will get T is equal to 1.6 seconds you will get. 1.6 seconds you will get answer. Check it, 1.6 seconds is there or not. So first option is the correct answer, right? First option is the correct answer in this case. So like this, different numerical problems are there. So at the time of reading the question you will get little bit difficulty, but when you try to apply the concept you will get clear picture. And we will meet in the next week. In the next class we will discuss another concept. Possible we will discuss another concept. Thank you very much all of you. Please practice and try to solve more numericals, then you will get better idea. Thank you very much.